We're going to solve this using the algebraic method for balancing. First, put down variables A, B, C, and D because we have 4 chemical species. We're then going to create linear equations based off of the quantity of each atom type: the iron, the sulfur, and the oxygen. There's 1 iron associated with A and 2 with C. Our equal sign from the linear equation comes at our yields or produces arrow. We do the same with sulfur and oxygen. Notice the oxygen occurs in 2 locations on the product side. We're going to select one variable, set it equal to 1, and solve for the rest. C was selected because C tells us immediately about A, and it also has the highest coefficient of 3 down there in our linear equation that we created based off of oxygen content. Once we know what A is, we can solve for D. Once we know what D is, we can solve for B. So we go ahead and we solve. When we do this, we find out that B equals 5.5. Since we're not allowed to have halves in our balanced chemical equation, we'll double everything. 2 halves equals a whole. This ratio that we created was true. We just have to maintain it when we arrive at our simplest whole number ratio. I'll now show the exact same thing using the traditional method, which is more of a trial and error, teeter-totter, seesaw method where you go back and forth trying to balance things out. Oftentimes it relies on a RAP table: the reactants, the list of atoms, and the products. This table allows us to very quickly see which things are balanced and which things aren't, which then allows us to put coefficients in front of each chemical species in order to get them to balance. This can be rather trying and rather tedious at times and requires several tips or tricks. Not all of these tips or tricks are necessarily known when people start doing this, and you can end up with quite a list of things that you would do so that you approach it just right. Remember, with balancing, there really are only 2 rules. You must have the same number of each atom type on each side, and it must be shown in the simplest whole number ratio for the coefficients. In working this out with our tips and tricks, we still arrived at having to double a half. It was just easier to figure out how many times 2 from the O2 went into 11. Now I'll show how the RAP table and the linear equations are virtually the same thing. Although, because oxygen gets broken up on the product side, some students don't necessarily see this. The other thing that can be confusing is that variables are involved and there's also an equal sign. This can throw people.